Example 8 from 3.3, find the equation of the tangent line. We've already done this several times this year. Find the equation of the tangent line. We find the equation of a line by finding slope. Okay, and if we go back to this page here, the first derivative of the given function is the slope formula for that function. So if we substitute the x-coordinates value into the derivative, that gives us the slope of the tangent line. Okay, so that's the whole idea here. Anytime you're asked to find the equation of a line, the question you need to ask yourself, how do I find slope? First derivative of the function, substitution of x into the derivative gives us the slope. And the x-coordinate is, it says, passes to the point 1, -2, the point of tangency. That's the x-coordinate we're going to use. All right. So in the case of this problem, how do we find slope? We find the first derivative. Now, if we take a look at the structure of the equation y equals x squared minus 3x times 2x minus 1, that is a product of two functions. So I could, in its current form, apply the product rule to find its derivative. I also notice, though, that it's just a binomial times a binomial. FOIL is very easy to do. Do a little bit of algebra. Creates a better structure that creates a power rule instead of a quotient rule. X squared times 2x is 2x cubed. X squared times -1 is -x squared. Negative 3x times 2x is -6x squared. And -3x times -1 is positive 3x. So just by doing a little algebra, I get 2x cubed minus 7x squared plus 3x is the function y. And now that function's in power structure, polynomial structure. So I can use the power rule. All right. If I do apply the power rule to find the derivative, y prime is going to be 6x squared minus 14x plus 3. That's the slope formula for our function. Again, the slope formula, when we did lines, the slope was a number, was a constant. When we're looking at curves, slope is a variable expression because it depends on what x equals as to what the slope is. So I know the point of tangency here is 1, -2. So step 2 of the process, again right here, substitute the x-coordinates value into the derivative to find the slope of the tangent line. My x-coordinates value is 1. Substitute 1 into that. I'm going to get the slope is going to be 6 times 1 squared minus 14 times 1 plus 3. That's just going to be -5. 6 minus 14, -8 plus 3, -5. Once I know what the slope is, it's the same problem we had back in Algebra 1. Find the equation of a line whose slope is this that passes through that point. Y equals mx plus b. Y is -2. M is -5. X is +1. B is what we're looking for. So -2 equals -5 plus b, so therefore b has to equal 3. So my equation of my tangent line is going to be y equals -5x plus 3. One other thing I want to mention about this, if I wanted to do the product rule here, function 1, function 2, take a look at what y prime would be. Y prime would be 1d2, that's going to be x squared minus 3x times 2. Plus 2d1, that's going to be plus 2x squared minus 1, sorry, 2x minus 1. And then times d1 is going to be 2x minus 3. Function 1 times derivative of function 2 plus function 2 times derivative of function 1. If I apply algebra after that, I'm going to get 2x squared minus 6x plus 4x squared minus 6x minus 2x plus 3. Which if I combine like terms gets me 6x squared minus 14x plus 3. Same derivative. But I just wanted to highlight again, if we do algebra first, it's easier to do calculus after we've done algebra than it is to do calculus first and algebra second. Okay, so just keep that in mind that when we're applying the product rule, if we have the ability to do some algebra to simplify the expression first, it's always better to go that route. Again, know how to use the product rule though, because it does have its purposes as we get to unsimplifiable expressions.